6.5 is exponents in scientific notation. So, we're going to start off with a definition. So we're going to talk about exponents. The definition for exponents is if A is any real number and N is a natural number, what are my natural numbers again? Not 0, right? 1, 2, 3, 4, 5, 6. Then A to the N equals A times A times A times A N times, right? That's what the exponent means. So that's a definition. So note, so for a little vocab, A is the base and N is the exponent. What's another common way to say the exponent? Some people say the power, right? To the second power, to the third power. So let's do some examples. So use the definition to rewrite. So first I have 2 to the 4th. So 2 to the 4th means I'm multiplying 2 by itself 4 times, right? So let's rewrite that. I have 2 times 2 times 2 times 2. 4 times, right? So what is that? 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, let's do another example. What if I have negative 2 to the 4th? I'm multiplying negative 2 by itself 4 times, right? So what's your answer? Still going to be 16. Good. Okay, let's do another example. So what's the answer for this? Negative 16. So I'm doing example 2 and example 3 because they're different, right? So the exponent only goes to what it's touching. Here, the exponent is touching everything in these parentheses. So this negative 2 is multiplied by itself 4 times. Here, the exponent is only going to the 2. It's not touching the negative. So I have a negative out in front, and then I'm saying 2 times 2 times 2 4 times, right? So this is negative 16. So example 3, example 4 are supposed to show that the exponent only applies to what it's touching. A lot of people use their calculator as a crutch, right? They think that if they have a calculator, everything will be easier. But a lot of people put this into their calculator wrong, and they get the wrong answer. And they're saying, I don't know why, I put it in my calculator. Make sure you're using your calculator correctly, right? And this is why. If we understand the rationale behind it, realizing that you made a mistake is a lot easier. I'll do another one. Here's everyone's favorite mistake. I'm going to write everybody's mistake. Everybody's mistake is that right? No, right? It's not right. Let's go back to the definition of exponent. If I have something squared, it's that thing times itself. So this equals x plus 1 times x plus 1, right? I'm multiplying this thing by itself twice. This is not good. Really bad. This is what the definition of exponent is, right? I can't tell you how many times I've graded a calculus test or a calculus 2 test, and people write this. Common mistake, right? Everybody's issue with upper level math is not the upper level math. It's, do I know algebra? It's the things we're doing in this class.
Do you do rainbow method after that?
So you would do rainbow method, which I think some people call as the FOIL method, which some people know as just distribution, right? So we're not going to cover it right now, but I will write out the answer because I know some people really like to see that. So you do FOIL or distribute. FOIL is first, inner, outer, last, right? So I'll write down the answer. And you can check my work if you want to. But maybe we'll talk about it later. I don't remember. I combine my middle terms, yeah? Okay. So that will be your final answer if you wanted to check it. But this is, like I said, really bad, but it's everyone's favorite mistake. One of them. Okay, so now let's do some rules. Rules with your exponents. So we'll call it the product rule. So what if I have x to the m power times x to the n power? What does that equal? Well, let's just write out what we know from the definition. So let's do example number 5. If I have x squared times x to the third, right, that's something very similar to what we're doing. Whether it's a number, whether x is a number or not, this is what we're doing, right? So x squared is what? X times x. X cubed is x times x times x, right? It's itself multiplying by itself that number of times. So what does this equal? I have x times x times x times x times x. That's x to the 5th power, right? Just using the definition. So what is this? What did I do to the exponents to get here? We added them, right? So if you want to memorize this rule, you can. It's helpful to make things quicker, right? So let's say I have x to the 12th times x to the 14th. You don't want to write out 26 x's, right? But if you understand the rules of exponents, you understand the definition, you can get to this, right? So let's do the power rule.
What would you do if you, because I know you used x, for instance, so it would be like the same variable, but like what if you had two different numbers? Would you still be able to just add the exponents, but what would you do with those numbers then?
So give me an example that you're thinking.
For instance, like instead of x to the second power and x to the third power, it would be like 4 to the second power and 3 to the third power.
Okay.
Would you just do the same thing even though you have like different numbers?
So let's write this out. So this is 4 times 4, and this is 3 times 3 times 3, right? I can't write that as something to the 5th power, right? Because it's different things. So here I couldn't simplify it. Good. So that's really important to recognize, right? So what Rachel just said is that they have to be the same base, right? But here my base is x, and so then I can add the powers. Here I have different bases, so I cannot combine them. Great question. Let's do the quotient rule. Okay, so the quotient rule says x to the m over x to the n equals what? Does anybody know? Well, I can't remember either, so let's write out an example. Oh. So let's say I have x to the 4th over x to the 3rd. I don't remember what it is. I'm on a test going, oh my goodness, what? Okay, x to the 4th is x times x times x times x. 4 times, right? X to the 3rd is x times x times x. Okay, now let's cancel our common factors. X over x is 1. So what am I left with? I'm left with x to the 1st power. So how did I get that? What is it, Gemma? Subtract. Good. So I subtracted. I said 4 minus 3 equals 1, right? If you don't remember, come up with an example. Again, they're the same bases, right? Let's do another rule, the power rule. So I have x to the m to the n. What does that equal? Oh my goodness, I can't remember. I'm on a test and I'm not sure. Okay, let me think of an example really quick that can jog my memory. Because m and n, what? Okay, so I have x to the 3rd squared. Okay, let's write out the definition, right? If I have something squared, it's itself, it's that times itself that number of times, right? So I have x cubed times x cubed, right? That times itself twice. Taylor, if it's too low, tell me next time. Oh, don't hurt your neck. Okay. So x cubed is x times x times x. X cubed is x times x times x, right? So here I get x to the 6th. So what did I do with these powers? Multiplied them. Good. So if you don't remember the rules, don't always do 2 for these. Choose different numbers besides 2 if you're trying to remind yourself of the rule, right? If you do x squared squared, that would be x to the 4th. But if you did x squared times x squared, that would also be x to the 4th. So don't always choose 2. In math, if you ever teach math, always using 2 is a bad example. Because 2 is really easy for a lot of things. All right. So if you don't remember these rules, come up with some examples. These do make things quicker, but I think if you understand the definition of exponents, that's the most important thing, right? Obviously, it makes this stuff a lot quicker, though. Okay, so let's do another definition. If a does not equal 0, then a to the 0 power equals, what's anything to the 0 power? It's 1. Anything to the 0 power is 1. And we're taking that as a definition. If I have a to the negative n power, what can I do with a negative exponent?
Can't you flip it so it's like if you have like 1 to the negative 3 power, then you just make it 1/3? Or no, you put 1 over, yeah, so you make it a fraction.
So if you have 3 to the negative power, right?
Yeah.
Okay. Similarly, if I have 1 over a to the negative n power, I can move that to the numerator. So if I ever have a negative exponent, I can move it to wherever it's not. If it's in the numerator, I move it to the denominator and make it positive. If I have a negative exponent in the denominator, I can move it to the numerator and make it positive. So those are definitions. Okay, so let's do some examples. Okay, so this is number 9. So I have 5 to the 4th to the 3rd. So what does that equal? 5 to the 12th which I think for your homework wants you to put that in the calculator then and come up with an integer answer. Five to the fourth times 5 to the third is what? Five to the seventh. What about 5 to the third over 5 to the fourth? Compute. How did you get that?
So I multiply, so I got 5 and 6 on the top part, and then I just.
So what are you doing for the rule here? I hear people whispering, but I can't tell what they're saying.
All I did was just like add them together, really. Like it says on the product rule.
So the product rule is if I have something to a power times that same thing to the power. So we should be looking at the power rule, right? So we need to multiply those. So this is 5 to the 9th over 5 to the 4th. And then what? 5 to the 5th. Now I'm subtracting, right? 9 minus 4 is 5. So I have 5 to the 5th, which again, the homework will want you to write 5 to the 5th as a number. So you can put it in your calculator, or you can do 5 to the 5th in your head if you're into a really good time. All right, so 3 to the negative 4th to the 0. 0, 1, I don't know. So whatever this is, anything to the 0 power is 1, right? If you wanted to go through and write 3 to the negative 4 times 0 is still 0. That equals 1. So you could either say, I have something to the 0 power, that's going to be 1, or you could use rules of exponents and say this is 3 to the 0 power. Either way, they equal 1, right? Let's say I have 2 to the 9th over 4 to the 3rd. What do you guys think? Well, they're not the same base, right? That's the issue. Can I write one of them? Can I write them as the same base?
Mm-hmm.
Yes, how?
I'm guessing take one of the powers, so like 2 times 2, and then that would be 4.
So are you saying like this, Mason?
No. I'm saying like
I think you are saying like this, Mason.
Yes. Yeah. Exactly what I'm saying.
Good job. So this is 2 to the 9th, right? I can write 4 with base 2. 4 is 2 squared, right? So I just rewrote 4 as 2 squared. Now I can use my rules of exponents. This is 2 to the 9th over 2 to the what power?
6.
To the 6. And now I'm subtracting. 9 minus 6 is 3. Let's do one more. Sorry. Let's do one more. 2 to the negative 4 times 2 to the 3. So what do I do with my exponents here? Do I add them? Do I subtract them? Do I multiply them? I add them, right? Add them. Negative 4 plus 3 is what? Negative 1. But I can write my negative exponent. If it's in the numerator, I can move it to the denominator and make it positive, right? So this is 1 over 2 to the first. So next time we're going to start with scientific notation. But let me take attendance